In this video, I'm going to introduce the individual demand curve. We'll start with an example. First, let's set the scene. It's late August. Maria is a 24-year-old graduate of the University of Iowa. She lives in North Liberty, which is a suburb of Iowa City, for those of you who are new, and works in downtown Iowa City, 10 miles southeast of North Liberty. There's a bus that goes from North Liberty to Iowa City twice a day, and it leaves Iowa City at 5:30 p.m. in the evening. Maria makes $50,000 per year. She grew up in Solon, where her family still resides, 10 miles to the northeast of North Liberty. She drives a hand-me-down from her parents, a 2015 Subaru Outback that gets 20 miles per gallon in the city. Now, let's think about Maria's weekly demand for gasoline. On Mondays, she has an important meeting at work that doesn't end until 5:45, which would make her miss the bus. She can't take the bus, so she needs to drive to work this day, and she's willing to pay $30 for that gallon of gas, which is enough to get her to Iowa City and back, so she can do her job. Notice she doesn't want to pay $30 per gallon for gas. Who does? She'd much rather pay $3 or $2, but she would be willing to pay that much to go to her work meeting. If gas were more than $30, say $31 per gallon, she'd take a taxi instead. $30 is the absolute most she would pay, even though she'd be much happier paying less. Maria also likes to visit her family for dinner on Friday night. This is important to her, and Solon is not on the bus route. She's willing to pay $20 for a gallon so she can see her family on Friday. If gas were more, she'd skip the dinner. She'd rather pay less, of course, don't we all? But she's willing to pay $20 to see her family. On Thursdays, Maria's friends get together for happy hour. Staying after work to see them will make her miss the bus. She loves seeing her friends and is willing to pay $15 for a gallon of gas to drive to work on Thursdays so she can stay late and hang out with her friends. A few more. She likes to go for hikes at Kent Park on Sunday. It isn't as important to her as happy hour or seeing her family, but she really likes to spend time in nature, and she's willing to pay $10 for a gallon. She also usually runs some errands on the evenings or weekends. She could combine this with one of her other trips, but she's not very good at planning ahead, and she would pay $8 for a gallon of gas to do the errands in a more convenient time. If gas costs more than $8, she'd make the effort to plan better. It's easier to drive than take the bus, so she would drive to work a third time per week if gas were no more than $6 per gallon. If gas were $5 per gallon, she'd drive to work instead of taking the bus a fourth time per week. If gas were $4 per gallon, she'd drive to work a fifth time per week. She likes driving through the country and listening to music to clear her mind. She's willing to pay up to $3 for this. Let's now make a table or schedule of how many gallons Maria will buy for every price. At a price of $35, she doesn't buy any gas. Remember, at that price, she'll take a taxi. At $30, she'll buy 1 gallon of gas. The only time she gets so much benefit from gas that she's willing to pay that much is getting to work for her meeting. No other gallon brings her enough value that she's willing to pay $30. If the price of gas is $20, she is now willing to buy a gallon to have dinner with her family. But note, at $20, she is also willing to buy the gallon to drive to work on Monday for her meeting. She's willing to pay $30 to drive on Monday, but she's much happier to only pay $20. So, scrolling down, when gas is $20, she buys 2 gallons of gas, one for her Monday meeting and one for Friday dinner. At $15, now she's willing to buy a gallon so she can drive to happy hour. But again, at $15, she will also buy her gallon for her Monday meeting and her gallon for her family dinner. So altogether at $15, she's now willing to buy 3 gallons. Continuing this line of thinking, at $10, she gets 4 gallons. At $8, she buys 5 or demands 5. At $6, she gets 6. I'm running out of room. At 5, she gets 7. This is what the board looks like when I'm working on a whiteboard, so it's how my videos look too. At 5, she gets 7. At 4, she gets 8. And at 3, she gets 9. And a key thing about demand schedules is we believe that, continuing our table, at 0, she does not demand infinite gallons of gas. We believe even when the price is 0, we will only demand a finite amount. So here, suppose Maria gets tired of driving. She doesn't really like to drive. She already spends a lot of time in the car going to work. So even if the price is 0, she doesn't want to drive any more than that. And so she'll buy 10 gallons of gas. Now that we have this table, which we call a demand schedule, we will make a graph. Economists put price on the vertical axis and quantity on the horizontal axis. We will label our vertical axis price per gallon and our horizontal axis gallons per week. At $35, Maria demands 0 gallons, so we will plot that point. That point indicates 0 gallons and $35. At $30, Maria demands 1 gallon, so we can plot that point. That point indicates 1 gallon and $30. Continuing on, at $20, Maria demands 2 gallons. At $15, she demands 3. At $10, 4. At $8, 5. At $6, 6. At $5, 7. At $4, 8. At $3, 9. And at 0, she will demand 10 gallons of gas. We are assuming that Maria can only buy gas in 1 gallon increments. But of course, you can buy half a gallon of gas, a quarter of a gallon of gas, an eighth of a gallon of gas. So possibly as gas falls from $5 to $4.50, she'll buy 7.5 gallons. So we'll draw that point in. So $4.50 would be about here. So that point is 7.5 gallons at a price of $4.50. Economists tend to assume we can always buy goods and services in fractions and that there are infinite number of points on our demand line. So economists tend to connect all the points and make a smooth line. Is that right? Honestly, probably not for Maria and her Subaru. For me, if gas fell by 5 cents, I would not buy an extra ounce of gas. But it makes our demand curve easier to work with, so we will go ahead and simplify. And once we are working with demand curves for the entire market, it is probably correct to assume that there are many, many people leading to many, many points on the demand curve, and that we can smooth the demand curve. So let's go ahead and smooth Maria's demand curve too, and we will connect all the points. And there we go. This is our first demand curve. So here is Maria's demand curve for gas. In this video, we have discussed first how much value Maria gets for every gallon she buys. We then discussed the highest amount Maria would pay for a given gallon of gas, what we call the willingness to pay. So she would pay $30 to go for that first gallon to go to her work meeting and $20 to go to her family dinner. And then we made a table showing how many gallons she would demand at a given price. And then we plotted the number of gallons she'd buy at those different prices. In the next video, I will discuss why our demand curve slopes down in more detail.